Hi, I'm Scott Pappas. At Motorola Solutions, we create software for everyday heroes. Public safety agencies around the world rely upon our cloud software and its unique capabilities to respond to mission-critical situations and protect communities every day. Join us for the Motorola Solutions Tech Talks on the Cloud, a virtual series hosted by Silicon Slopes. Throughout this series, you will have an opportunity to learn about the best practices and patterns we use at Motorola Solutions to develop, deploy, and operate cloud software and services. And I'm going to get started with the presentation today. And if you have any questions, just put it in your chat and the moderator will put it in my Zoom chat for that I can respond to either during the presentation or at the end. I'm going to share my screen really quick. Okay, so hopefully everyone can see my screen. So today we're going to talk about the availability of cloud solutions. Again, my name's Scott Pappas. I'm the architect of our next generation 911 solutions here at Motorola Solutions. So if you look at the top three cloud service providers, Microsoft, AWS, and Google, if you look at their availability, they range they top out depending on what solution you're trying to do. They top out at somewhere between 99.9% or 99.99%, some or even. And so we call that the number of nines. So if you look at 99.9%, that's 3 nines, and the next 99.99% is 4 nines. And some of these even can approach 5 nines, and we're going to talk further about that. However, there's definitely a catch. If you look at recent failures across the cloud, I'm going to talk about a number of failures that have happened to each one of those cloud service providers. So in September 2018, they had lightning and multiple other events. It was just like a multiplicity of errors that took out their South Central region and another neighboring region. And it took it out for some time, like at least a half a day. So in June 2019, this is a pattern that often happens, error in configuration affected services in multiple regions, so which took them down in many of their services down in the Google Cloud for up to 4.5 hours. And then finally, the one we're going to look at is in September 2019, in AWS, a power outage in the data center resulted certainly in loss in that particular data center, and in a neighboring data center was okay, so that's good, and we're going to talk about some of those constructs. However, in this particular case, some data was permanently lost, and it took days and months, and some of the data was actually not able to be retrieved. Hang on one sec, I just want to move that out of the way. So how much is good enough? And this slide, we're going to talk about, okay, so what do those nines really mean? So if we focus on the right side, we see 2 nines. What this means is that on the right side is how long during an entire year, if you were operating at 2 nines, what's that mean? So in this particular case, it means that, okay, well, you could have up to 3 days and 15 hours of downtime during the year. It could be dispersed across the year, or it could happen all at once. So 3 nines is 8 hours, 46 minutes, 4 nines, 52 minutes. And then 5 nines which is really kind of the pinnacle for from a practical sense, means only 5 minutes and 15 seconds of downtime. And so this downtime doesn't necessarily need to be, something's wrong with the system. It could be that you are maintaining your system. So how do you design your system to be maintained? You take it out of service, or do you design it in a way that you can maintain it and there's still services going on, which is obviously preferable. So that's what it means. So if we frame this in the term of like, all right, so I've got all these different application types. Not every application needs to be 5.9s. Obviously, you'd want to be 5.9s. That would be really awesome. But I don't think any of us would want to spend the development time or the cost to do that. But if I just frame this in Motorola type of applications, so say from the top, maybe one of our least critical applications was putting a customer facing portal or a dashboard or something that we were tracking, status of a system or what have you in front of a customer or order placement. That'd probably be the least. And so maybe we wouldn't necessarily put all the time and money on that. However, as you move down the stack here, I'll just pick on one, 911 call traffic. When you dial 911, you really expect that call to get to the dispatch center such that they can bring help to your house. And in order to do that, once they get that call at the dispatch center, a public safety a professional uses either our communication systems to communicate to the police, fire, ambulance, or what have you, to dispatch them out to your house. So those things absolutely need to be there. So those applications, and including critical infrastructure, you do probably want to put the time and money to get down toward the bottom of the scale. Okay. Okay, what is availability? So availability is mean time between failure, all over mean time between failure plus the mean time to recovery. So if you look at that, that's pretty simple. That means that if you minimize the denominator, so minimize the incidence of failure and make the recovery time as short as possible, your availability should be awesome. And so that seems pretty easy. So why is this so hard? Well, it is not as easy as you think, but what I'm going to talk about is some tools in the toolbox that you can leverage. And we're going to talk more about these through the rest of the presentation. So attacking, every entity has some mean time between failure. Every machine has a failure. Every machine has CPUs. Every machine has hard disks. They have other parts, networking cards. Those fail, and they always will fail. And they have some sort of, mean time between failure. So we need to plan for that. So how do we do that? So we eliminate, we give redundancy. We put redundancy in the system. We eliminate. You need to examine your system for any sort of single points of failure and remove those. And then we also need to embrace service clustering or multiple workers. So what this means is that instead of having say a single application on a machine that's its job, it's deployed on one machine, and in order to get that job done, that machine, the application on that machine needs to get that done. And if that machine or application fails, well, then you're kind of SOL, you're stuck. So how we get around that is we leverage something called service clustering, and we deploy multiple applications or processes that do the same thing, and then we balance the load across all those, such that if one fails, it's not a big deal because there are other worker nodes that pick up the job. And then the next thing, which is very important, and is to create independence. And what this means is that you need to spread your services across different failure domains, because as we talked about in these cloud failure cases, all these different cloud providers have different tools in the toolbox to address this, and they have different failure domains. So like, for instance, in the case that you're in AWS and the power went down, if you had your services in that particular data center and they weren't in any other data center, then you're done. You would have had the outage for as long as they would have had the outage. So understand what the failure domains are and place your services across. And then the MTTR. So you need to optimize your failure detection, and it's really mean time to recover is failure detection. So how long does it take you to detect the failure, plus how long can you do something? How long does it take for you to do something about it? This needs to be looked at very carefully, because you need to really tune this to your use case, because typical cloud-based tools, they have defaults in the tens of seconds, if not 30 seconds, a minute, and that may not be appropriate, or it might be perfectly appropriate, depending upon what your application is. Okay, how do you calculate your 9's? In this particular case, if I had my process had a serial arrangement of services, and I had a 3.9 service, a 4.9 service, and a 3.9 service, and I'm going to calculate the availability of that. It's simple. You just multiply the availability across each one. So this collection of fairly, moderately high availability services, when you serially couple things, it degrades availability. So every service you have is above 3.9s, but yet I result in a total availability that's not even 3.9s. It's a little more than 2. So the availability of services in serial is always less than each service individually. So the moral of the story here is you really need to think hard about cascading services serially. And you have to. There's always cases you will have services stacked up against, but you need to minimize that as much as possible. A much more preferable arrangement is if you arrange things in parallel, and this has to do with the service clustering that we just talked about. In this case, I've got 3 services. 2 of them are 2.9 services, and one of them is a 1.9 plus, almost 2.9s. So if I do the calculation here, the end result's a little bit differently. So I can take these sub or 2.9 or sub 2.9 services, but in parallel, all 3 of them together results in a 5.9s type of solution. So availability of services arranged in parallel is greater than each service individually. And that's why things like clustering and what have you, being able to distribute load across multiple instances is a very powerful concept, because especially if you do things in a clustered in N+1 fashion, where if one drops out, it's not a big deal. You have enough workers to handle the load. And the cool thing about clouds, services in the cloud is they can dynamically scale. They can dynamically scale to spin things up and down based upon your workload as well. So when you go on the Azure catalog, service catalog, or AWS service catalog, or Google service catalog, they're going to talk each one of these services, and there's a section for the services called SLA, and that's called service level agreement. And so in this particular example, I have a VM scale set, which is a very important concept for the clustering, and it's a key component. It has an SLA of 3 9s. So I'm thinking, all right, that's cool. That's a known fact. I can take that to the bank. It's 3 9s. In this case, I've got an Azure load balancer. It has SLA of 4 9s. So, okay, so this is good. And then Amazon Route 53 DNS-based traffic management, it has an SLA of 100%. Wow, that's super awesome. So I'm well on my way to creating my very highly available system with all these tools. So does the SLA mean availability? So this is a quote taken from the SLA terms of service from the Azure catalog. So I'll read it for you. If you do not achieve and maintain the service levels for each service as described in this SLA, then you may be eligible for a credit for a portion of your monthly service fees. So what that means is that the SLA is a business instrument between you and the cloud service provider that details service credits for non-performance. So it's an indicator, but certainly not a guarantee that a service will be available. So that's very important. So you can use that. Like, it's really hard to understand what the true availability of a particular service is. And really, they don't publish actual measured numbers. So you can use these as guides, but these are upper end guides to be sure. I mean, really, nothing's 100%. That's not possible. But you don't really, at least in my business, at Motorola Solutions, if our system went down, we're affecting lots of customers. It's really hard to feel good about the fact that we have a service credit coming back to us from either AWS or Azure. So we really need to use these for what they are. They're more indicators than they are actually availability guarantees. Okay, so we're going to talk about some of the design constructs that you have when you're building out your solution. So the first thing that we talked about is scaled workloads or clustered workloads, however you want to call it. In this case, in a single data center, we can place VM scale sets and we can deploy them across multiple fault domains in the data center. And those are called availability sets. And what that means is that they segment the data center. The availability set means that they have different failure domains. So they have different top of rack power and different top of rack networking in one availability set from the other. And they also do upgrades in one availability set while not touching the other. So like, for instance, if you had a top of rack power supply fail, it would affect services most likely in one availability set and not another. So there's some level of redundancy there, and that's good. And as we go forward to the right, there's going to be higher availability offered. The next thing we can do is all cloud service providers offer the concept of availability zones. And what that means is separate data centers that are on different fault domains. So they have separate electrical, And they have certainly separate electrical, separate networking, what have you, to those data centers, and in separate cooling and what have you. And in most cases, they're separated by some physical distance. Okay, it's not as much as a separate region by any means, but it might be two of them one on the other side of town. The only reason I kind of hedge my bets in many cases, they're separate data centers. I know of one Azure two availability zones. They're physically housed in the same place, but they are in separate buildings, all separated by different power and what have you. Okay, so the next thing we look at is true geographic separation. So we can deploy all those constructs, different availability zones, and I think the point that I should have made that I didn't. So if you have let me back up one sec to availability zone. If you have a failure of in an availability zone, it should not affect the other. Okay, not saying it's 100% because it's not, but it should not, because they're on separate fault domains, unless some other failure happened that was something different than the fault domains that they planned for. In fact, that Amazon failure that I talked about, in that case, then actually this AZ was down and the other one was unaffected. So, but now we're talking about multiple regions. So these are physically, logical, and geographically separated fault domains. And I mean, you always deploy into a region, some region. And so what this means is that, well, you have two or more. And you could choose to say you had an application that, I don't know, maybe you're processing audio or video, and you had two regions that one was on the East Coast and one was on the West Coast. Well, you can do clever things like load balance geographically to get you closer to the region to reduce your latency. I know Azure Traffic Manager has that function. But if the theory is that if we have a failure that took out the entirety of region A, our services are not going to be affected in region B. Okay, so now we get really paranoid. So what happens if the entirety of Google went down, Google Cloud went down, and so my workload just, it's unavailable? Well, one thing I can do is I can distribute my processes and my application across multiple cloud service providers. So what this is saying is like, do everything that we just talked about, say make a multi-region solution if you see the need to, and then apply at least a subset of that solution in a completely separate cloud service provider. And all the cloud service providers have the same construct. However, that's your most complex solution, because your deployment is likely different. And if you tend to use mini platform as a service, or what's known as PaaS services, those are going to be different across different cloud service providers. So you may have to change your software to be able to support that. Okay, so why wouldn't you always just go all the way to the right? Well, because it costs money and it takes time. So this is really kind of a table summarizing the previous chart, but if we look at the base case, I got a single VM on a machine sitting in AWS. I got storage, that's it. That's my base case. That's like a 1x. Now, if I start moving forward and say, okay, I'm gonna do clustered workloads. I'm gonna have a load balancer. I'm gonna leverage availability sets. That's okay. That's a 3x multiplier from the base case. Now I'm going to layer on multiple availability zones. So it's a small, that's actually a very reasonable step to take, because there's quite a bit of bang for the buck from you to get from one to the other. One thing I wanted, well, anyway, I'll talk about it here. So we think that you can get to, like, in a clustered workload, we think you can approach 3 9's. If I go to multi-availability zones, I can approach 4 9's. And the reason I say approach is because there's some other failure cases. It really depends on your application. If you have any serialized nature, or the availability of, availability zones is truly not according to their SLA, then it's going to be less than 4 9's. But you can approach 4 9's with multiple availability zones, but you're going to pay 4x over the base case. Now, if you jump to multi-region, which you can start to get close or approaching 5 9's with multi-region, that's like an 8x multiplier, or twice as much money as just doing multiple availability zones. And then, of course, if you take the added step of going to multi-cloud, it's 12x or more from your base case. Now, I wouldn't say the base case is, most people are going to have more to their application than that, but you can use this as in relative terms. So the other thing is that we talked about is when we look at those failure cases, the reason you do all this stuff is to create independence, different failure domains, okay? So that means that, we had failure cases that took out parts services in multiple regions, okay? So if you were here, or even here, that was like 4.5 hours or 8 hours. So that you can create a solution that is approaching 5 9's, but if in those cases in June 2018, you would have violated your goal, because if you were in those regions, and that if you really wanted a 5 9 solution, you would have had to been in a multi-cloud solution. Okay. Key design tenets. So I think Netflix is probably the best example of this, and you can go just Google Netflix and chaos and chaos engineering, and they've done a phenomenal job of embracing and plan for failure. And they plan for it, and they take their system down while it's running all the time to make sure that you can always watch the movie that you want to watch. But you need to embrace and plan for failure, both things that you plan on, like maintenance events, and unplanned. In order to do that, when you start your design, you need to do a failure mode analysis. And this is sitting around with a few key people and looking at your architecture and thinking about what can fail. And anything can fail. Networks, the cloud services, your workload, your application, the infrastructure that it runs on. And then the worst case is that it doesn't just fail. Like, that's actually the easy case, when something like, okay, a hard drive went bad, that's toast. I have to work around that, or I have a network path that is blocked. We can get around that. But what's really bad is when you have grave failures where things work slowly or work intermittently, or they kind of work. That's actually the worst case. But look at your services and both, look at your services You may call a microservice. And that's simple. What happens when I didn't get a response to my REST query in a required amount of time? What do I do? Do I just hang? Or do I have a retry mechanism and I retry a couple of times? And then if that doesn't happen, something else happens. So do your failure analysis and then document what the failures are, and then how you can mitigate them. And really what you need to do is rank those, because there's going to be a gajillion of them, and you're going to need to prioritize them as to what the effects are and what do you think the probability of occurrence is. The next thing that may affect some of you is minimize your stateful workloads if you can. Embrace stateless designs. And if you have state, which some people do, depends on the application, and you can't get around it. You need to identify that state and externalize it if possible, or contain the state. The worst thing you can do is have state go throughout your entire solution, because it's very difficult. If you have failure and recovery cases, keeping the state consistent across all your worker nodes is, especially if you do multi-region work, is a nightmare. Leverage the cloud constructs that we talked about. Multiple instances of services, availability, sets and zones, and in the multiple geographically diverse regions. Failure and recovery, we talked a little bit about that. So it's an interesting topic because it's in the denominator. So you'd like to reduce your failure detection time as much as possible, but you also don't want thrashing of your network. So let's say you had a multi-region solution and you wanted to minimize that as much as possible. So you had a health probe and you wanted, if that thing did not fire back within 5 seconds, you wanted to switch regions. Well, switching regions is a big deal. So you have to think about what happens when you switch. How do you determine when it's time to switch, and what does it mean to go back? All those things need to be thought out. The next thing is a very important concept. Establish bulkheads wherever possible. Let's take I'll take a telephony or a communications example. Let's say I'm doing a telephony application in my region, and I have state of where I am in the call setup phase. And if I have a failure, the obvious thing to do is replicate that state across the region. But maybe the reason that I had a failure is somebody injected, like I had a defect in my system and they injected in the call signaling path some pattern that caused, the application solution to go belly up. So if I were to preserve that call and switch regions, I would apply the same stimuli to the application, and I would have successfully taken down both of my regions. So it's a trade-off. So really, you want to have bulkheads where, in this particular case, I could have a bulkhead between region 1 and region 2 and say, okay, we're not going to preserve state across regions if we happen to have state. If we happen to switch regions, then I'm sorry, the calls in progress they're going to go. That's just unfortunate. However, but I'm protecting myself from an entire system failure. So I know Microsoft and some other companies actually go to the extent that, like for critical services, they may actually have redundant systems, and they may have one system based on, like, let's say they're doing a DNS solution. They may have one system that is based on Windows, and they have a redundant system that is based on, application software in Linux. So that way, they isolate themselves from any sort of software virus or anything that would take out both. That's an example of bulkheading. So multi-cloud can require a different solution set, and we talked about that a little bit. If I'm using like Cosmos DB in Azure, and it's a great database, so I want to use it to its fullest extent. So I'm using the API that's defined. If I go to AWS or Google Cloud Services, they'll probably have a database that's similar. However, it doesn't have, most likely it doesn't have the same interface. In fact, it's almost guaranteed not to. But many of these past services have what I call least common denominator interfaces. So you can back off to it may emulate a different, like an open source database. And if you do something like that, then you can have a good shot of maintaining a consistent interface. Otherwise, you need to write a wrapper around it to isolate yourself. And then, yeah, so, or you use open source components in that case, if you know you're going to do that. Okay, so I'm getting close to the end here. So in summary, determine your availability needs up front and be realistic. And we all have product owners, and there's a healthy tension between product owners and development engineering. And the tendency is to always go, to the high end of the availability curve. But if you're developing like a catalog-based shopping app, do you really need to be 5 nines? So maybe disaster recovery is more important. That if I do have a failure, I'm not going to lose any data, and I can restart my service in another region. It doesn't have to be active. I could do active standby, but since I did a good job of making sure my provisioning data is kept up to date in both, then that can be a realistic solution as well. So be very realistic and ask good questions about what are your true availability needs. Do the design early. It's once you get so far gone, it's not easy to iterate any longer. You accrue a lot of technical debt, and adding on highly available solutions is not trivial if it's not planned for up front. Again, do your failure analysis early, and no one really likes to do this. Everybody always rolls their eyes at me when I said, okay, we need to do failure analysis. But until you do, you cannot, you can guess at a couple of general mitigation strategies for some common failures, but every solution has their unique needs and nuances of how it's designed. So it's very important to take your system and look at it and try to figure out how it's going to fail. And then cloud service provider availability SLAs are truly business SLAs. They are not guarantees. You can and may get credits off of that, but that's it. The reason you want to do the first one is that designing to higher levels of availability is non-trivial, and it will increase your cost both from a money that you pay the cloud service provider as well as your development dollars to develop the solution. And then I put this in as a blurb because I found it super enlightening. This was a great reInvent. AWS does this reInvent series every year. And I would encourage you, if you think you're doing, if you want to achieve high levels of availability and you want to do multi-region active-active designs, you really need to go watch this. It's about a 30-minute watch, and it's really, really enlightening. And it can be applied to any cloud service provider. So I highly encourage that. It's very instructive. Okay, I've reached the end of my presentation. I'm going to stop sharing now. If anyone's got any questions. Okay, if there's no questions, I hope everyone took a little bit away from that today, and I wish everyone